Hello to everyone. My name is Alex. I'm from Czech Republic, and I will present you the bandwidth manager with MikroTik. So there is a 2.0 because I had similar presentation in Cape Town this year, or 2017, and people liked the presentation and they asked me to make it again. And I improved it. I put a lot of real practice examples and configuration examples to that presentation. So, and this presentation is technical presentation, but I also try to put some funny things to it and to entertain you a bit, and I hope that you will not sleep during my presentation. So, first of all, I will check who is not sleeping now. Who watched the movie Guardians of the Galaxy? Just raise your hand up. Come on, IT guys, you must know it. Okay. So plenty of people watched it. It means that you understand the stories and some jokes that I try to put there. And let's start with that. I'm Root. I'm Groot. You know, every Unix person is a bit of Groot, because Root is the main administrator to Unix systems. So this is why this guy is my favorite character from movies, and that's why I have the t-shirt with this guy, and he will help me to find the right pictures for my presentation. If some pictures will not correspond or will be incorrect, that's not my fault. So it's a Groot fault. Okay, a few words about myself. I'm a MikroTik trainer. I do train people, and but my main business is billing software. So we have a billing software that we sell to internet providers. At the moment, we have over 250 installs in production networks, and we have around 20 employees who are developing and selling and supporting this software. I do a lot of BGP, OSPF, and MPLS, and as I'm saying, other magic in the WISPs and ISPs networks. And originally I started with Cisco, so I'm a CCNP engineer, and I also work with the Junipers, with other vendors, but I'm a big fan of MikroTik, so that's why I'm presenting here. If you have any questions about my presentation, you can meet me. We have a booth there, and so I speak these 4 languages. You can speak with me and ask me any questions about queues, about software, about BGP, anything. Use tools. Oh, that's the first slide. Okay, these are the use tools by Raccoon from the movie, but my use tools in this presentation are MikroTik CHR that I run on VirtualBox. So I will show you the examples of the configuration here on my laptop. I work a lot with the EVA-NG Labs. So this is a good tool that I recommend you to use. It's free, it has a community edition, and it's a former Unit Lab. Now it's called EVA-NG, so it's something, I'm pretty sure that you know GNS3. Every networking person knows it. So this is the much better platform where you can run different vendors and different equipment, and especially you can run MikroTik there and test all your configurations before you put it to production. And I run the Ubuntu with my software to create some queues, and I use MikroTik API for creation the queues in this example, but we'll talk about how to create these queues in a central way, in an automatic way. Okay, so this is the EVA-NG example. So for example, this is the topology that I run in my office. That's on one computer that I have it, and there's a Cisco devices like ASR routers. It's Juniper devices, and especially all the small boxes, you see the access points, they are MikroTik routers. And I can try my MikroTik, all the latest releases and release candidates without touching my real network. I can just have a small lab with similar network topology that is in the production, and I update my configs there and I check if everything is working fine or not. So I recommend it to everyone, EVA-NG, free tool to use. So are you ready? Let's start the presentation about the bandwidth management. Policing and shaping. So everything starts with these 2 words. Policing and shaping. All these bandwidth managers, quality of systems, they all are based on the policing and shaping. In MikroTik, we operate with the chains, queues, all these terms we will discuss right now during this presentation. What is that about? So Groot, please show us what is the policing and shaping about and what is the difference. Oh, politics and shaking. No, that's not the policing and shaping. Please add some chains there and make it the policing and shaping. Yeah, no, this is not. Groot. Okay, I will not ask him anymore, so let me find my own slide. So this one, policing. Okay, so the policing is when we have, so for example, we have a customer running 10 meg link or 5 meg link. So if he is pushing too much traffic to the link, we want to slow him down. So the policing is the first approach how we can do it. It means that we will drop everything what is just above the line. We'll drop all the packets. And the shaping, the difference is that we do not drop it silently, we just put it to the queue, to some memory, and then we take, or MikroTik takes out, or any other vendor, takes out these packets and sends it to the line. So the policing, it's, as I'm saying, drop all packets above allowed limit. We can set it up in MikroTik with a queue size 1 for our queue. And the problem of this approach is that TCP connection should be reestablished and the UDP packets are lost. What does that mean? It means that your customer, and that's the next slide, when we have policing of 5 megabit per second, you see that my speed on speed test that my customer sees is around 5 meg, so that's fine. But the problem here is that I'm losing my ping, so the UDP packets are also lost. So the plenty of packets are lost here, and this service that is related to UDP will be affected there. The bigger problem will appear as soon as we will provide higher speeds. So this is the problem, 20 megs. You set up 20 meg with a queue size 1 packet, and it will provide you the speed test of 11 megs. And then I promise you that your customers will complain, and they will say that something is wrong. So here we do not see the loss of packets because it's quite big speed, so the pings are not lost, but this is the big problem, and many of my customers, they complain because they set up the incorrect queue type, and they say, okay, we are providing 50 megs or 30 megs on PPPoE, but my customers are getting only 25, only 45. What is wrong? So the wrong is the queue size. And so as we see, the queue size 1 is not good. So that's why we have to start talking about shaping and use shaping. In this case, packets are put to queue, and from the queue they are taken out by CPU. Please note this is a very important word because they are taken out by one core in MikroTik. We'll talk in next slides, I will show what is the impact of it. Packet order is important for us. You know, there are queue types, you can read it on wiki, what are the differences. The router can take packets from the queue in a certain algorithm, so it's first in, first out, or it's the PCQ or others. I will not talk here deeper about that queue types. Rather, I will explain the queue, the different approaches how to build the queue trees or simple queues. So what is important here is to set the correct queue size. When we need to set, okay, so this is again example. Shaping with the 5 meg, you see there is almost not that big difference comparing to the policing, but before all the ICMP messages were received in 15 seconds, and here the delay was added. So the delay is 500. So this is the difference between the policing and the shaping. The shaping puts it to the queue and then takes out the packets from the queue and sends it out to interface. So that's why when the link is overused, we will see not the packet lost, but we will see a lot of delays. Some packets will also be dropped, but here in this example it shows that we see the delay. And again, I have a problem here because I set up the default small on my PPPoE session, and again, my customer got 20 meg link, so I'm providing fiber or some nice wireless link, so he has the 20 meg, but he can get only 14 on his speed test. And he starts to call me, why are you providing me this slow speed? And the main problem is really, it's hidden, but it's very simple to fix. You just need to change your queue type from, or the queue size. So here's the 5 packets, and when I change it to 50, the queue size, then it starts work as it should work. So this is just the basics of the queuing, and I hope that you understand what I'm talking about, and you will use the right queue size in your shaping configurations. Okay, shaping queues, HTB, PCQ. We'll talk about the simple queues, we'll talk about queue trees now, and about mangling, about all this related thing. What we can manage with queuing in MikroTik. The most used application of this is limit customer speed. So I have 1,000 customers in my network, and I want to give them certain speed, so this is my usage. Also, I want to allocate the bandwidth to some applications inside my network, and that I can configure my quality of service for that. And also I can set up the high priority for some kind of traffic inside the network or on the customer device. So it's all about the queues. Okay, Groot again found something related with trees and apples. No, we are on MikroTik shaping. Queue tree is the first type that we will talk about. And I will show examples on mainly on related to customer speed limitation. Queue tree with PCQ address list. So this is enhanced version of queue tree that can bring you more power, more performance. The third one is simple queue. And then we will take a look on the fourth option, how to limit the speeds of the customer, which is called simple queue with parents. Queue tree, the first one. Queue tree, correct. Okay, queue tree, need to mangle all. So the queue tree, for example, you have 600 customers. You need to mangle all the incoming and outgoing connections. So it will be 1,200 mangles. And then you need to create queue tree for each single client. So tree with multiple levels. I prefer to use it for traffic type prioritization. I don't use it for bandwidth speed limitations for customers, and that I will explain you why not. HTTP global is used for queues. So, and this is where HTTP global is located. So it's located before simple queues. And the problem with this type of shaping, if we apply it for customers, but not for the bandwidth limitation, or not for the bandwidth prioritization for applications, is that when we have a lot of mangles, it will kill our CPU. So this is the Cloud Core 36 running 600 mangles, and 200 megabit per second is killing the CPU completely. So it's 100. So this mangling, a lot of mangles, it's killing the CPU of the Cloud Core and any other. So it looks that really this type of shaping is not ideal for if you want to set up the speed limitation for customers. Okay, showtime. Let me show you what I was talking about, and I will show you where we can use that. So we can use it in the quality of service setup, but don't use it in speed limitation for clients. So here I have a MikroTik router. Just let me connect there. And there's what I was talking about. So this is an IP firewall. So I'm showing the incorrect way how to do that. So you will understand that please don't do this. I'm doing the packet mark or mark connection for incoming and outgoing connection per each customer. That's what I do here. I mark the packet called test customer, for example, and then I have a queue tree where I set up, you see the parent is global, and where I define the speed for this client upload and the speed for this client download. So this is, if I configure my Cloud Core this way, it will lead that my Cloud Core will die in 200 megabits per second with 600 customers, for example. Then how we can use it? We can use it for providing quality of service. So first of all, of course, if we will have less mangles, it will help us in performance. And there is an example how to use it, for example. Okay, let me export the configuration or import file, and there is a mango with a capital. And the second one is Q. Okay, so this is an example, IP firewall. Let's take a look on it. You see there are some mangling of traffic, but not per customer, but per application, per port. Some of them are per port, and some of them, for example, here is a speed test mark, that if advanced. If the content has a speed test, we mark this packet and then allocate some bandwidth to this traffic. I have all these rules available on my GitHub, and I will share with you the link so you can download it and just play with it and tune it and work. So when I mangle all these packets, different packets of applications, I can set up the queue trees. I set up simple queue trees here. I mean, very easy without upload and download. It's taking everything, traffic both directions. And here I can define that, for example, on that link I have on that router, the maximum speed is 10 megabit per second. So this is the root. So you see, this is the root, and all other applications are in the children-parent relation. All the queues are under that main root. Here is the VoIP, for example, and each has own speed limitation and limit at and priority. So if you work with the queue tree this way and define your quality of service on access point, on CPE, or even on the main router, that's still fine. That's good. So it will work well. On main router, I'm not sure about that, and I will tell why. But on the CPE and access point, that works quite well. Okay, let's continue to the next type. And that's improved queue tree. So it's a PCQ and address list. Again, we will use queue tree for our speed limitations, but instead of, for example, for 600 customers creating 1,000 mangles, we'll just set up the mangles per plan, per internet plan that we provide, or per group, or per pool. So it means that instead of 600 rules on the mangle, we will get only 50 or 30. So it means that our processing power will not be killed by going through all these mangles. And this type of queuing was used a lot in the past, before cloud core routers. And still some people use it. So what are the benefits of it? Really less mangles we need. Internal PCQ sub-queues that are responsible for speed limitation. It's very fast on x86 with powerful cores. And it was used a lot in router OS 5 and previous. And for Cloud Core, it's not a good option. Why it's not a good option? Because only one CPU can take packets out from the HTB global. MikroTik is working on possible update, or they will introduce completely new methods. So that's what we found on the information available. And use interface, so this is what MikroTik says, use interface HTB as much as possible to offload traffic from not the interface instead of global. Or use simple queues. So it means that, again, I have the PCQ, I have less mangles, but my queues, if I have, for example, 500 megabit per second on my router, 600 megabit per second, then the queue will become quite big, and one CPU is used to taking out the packets from it. And that's why Cloud Core do not perform well on this PCQ with address list. And that's what we found in reality, in real life, because as I'm saying, we help with the integration of our software in hundreds of networks, and I see the real production Cloud Cores, how they work. So some people had this kind of shaping, and they say, look, I cannot push over 700 megabit per second through my Cloud Core. What's happening? Why I'm doing something wrong? And then we started to read about that and to understand how it works exactly. And we found out that this type of shaping works very well on the powerful cores on the x86 machines. But as soon as you put it to your CCR, then it will not be that great. Okay, showtime. Quickly, I will show you what I'm talking about on the example. Okay, here we can set up, let me check that, because I have the API connection to that router, and what I can do is I can set up the proper rules without making them manual. So this is the way how you can do it also. You can create your own scripts. We do work a lot with MikroTik API. MikroTik API is really awesome. It works very, very well. It's very reliable. And I recommend you to use it or use Radius. So we use also Radius created queues, but this type of queuing is not possible to create through Radius, so that's why I use API. So what I will do here is I will set up the PCQ address list, save it, and now I have to wait a bit when it will connect and reestablish, we reset up my my queues there. Okay, IP firewall. I have here still some rules. And okay. Here, what will appear in this place? In this place will appear all IP addresses of my customers. So it will be set to the address list. So that will be the first step. The second step of this type of queuing will have IP firewall, and under Mango, all these Mangos will be removed. I can remove them, and new Mangos will appear. And then in the queue tree, we'll set up the queue type, the PC queue. Here it starts. So here it was updated now. And each has the speed limitation inside the queue type here. So okay, let's take a look again. IP, firewall, address list. So you see there are all IPs of my customers that I have configured there. Mango. So all these Mangos are used for marking the whole traffic of my customers. So it doesn't matter if I have 500 clients. I will just use this amount of Mangos, this small amount of Mangos. I mango it. If I open each single Mango, it shows me that I have address list. You see destination, there is also source address list. So I mark the packet based on the IP address that is put to address list. And then when I mango this traffic, action, there is a packet mark, and then I go to the queue. And inside the queue, there are the queues, each per plan. Again, there is no 600 queues. There is just, if I have 10 plans in my network, I have 10 queues. And each client from this plan is pushed to his queue. And this queue is overall for all customers in the plan. If I click on the queue type, there are special queue types. And if I open it, there is you see total limit, rate. So rate means the speed per customer inside the PC queue. So this type of shaping was used a lot in the past and still it's used. It's called PC queue with address list. And you can find information about it in other presentations from MikroTik or on MikroTik forum or on Wiki. And as I'm saying, the main disadvantage of that is this approach doesn't work well on cloud, on CCRs. So if we need to work with simple queues, then take a look on the simple queues. So the simple queue is simple, like it Rex, but very powerful in cloud, in CCRs and in version 6. It's still sequential, but matching algorithm was updated. Very fast, multiple core support, and it can be used with radius. So it means that if you have some radius server, you can set up the speed limitation and it will create the queue dynamically when the client is connected over PPPoE or over DHCP. Simple queue radius, automatic creation and radius attributes we use. And I recommend you to use this type of queuing because really it helps you so you don't have to manage it manually if any radius server allows it. And then you can change the speeds on fly. For example, if you need to disconnect the client or slow him down a bit if he is downloading too much. And it allows you the implementation of fair user policy. This is the example. The CPU usage is on a simple queue 4%. The traffic is, I think, 300 megabit per second, and there are 2,000 simple queues created in that router. Now that's the screenshot from the live router. 12% CPU usage, over 2,000 queues, and over 300 megabit per second traffic. So if you compare it with the first one, you see that the first one completely died, and this type, it just gives you 12%, which is nothing. And of course, because as I'm saying, I have access to many different networks, my customers share with me their experience and share with me how Cloud Core performs in production. If I have 1036 router, it allows me to run around 1,500 PPPoE session maximum with a speed of a bit over 1 and 2 gigabit per second through the whole router. As soon as I reach this amount, also please know that PPPoE is involved here. So all this encapsulation, decapsulation is also reducing the performance. So if I will not have the PPPoE, probably the speeds will be higher, but unfortunately all my customers, with this amount of clients on one router, they have PPPoE. And in this case, we'll have 80 up to 90% CPU usage, which means that some packets will become lost and the clients will start to complain. And as I said, all these queues were created by radius. If we take 1072, it's almost double performance. So up to 3000 PPPoE and queues, and up to 3 gigabit, less than 3 gigabit, 2.5, and it will bring you to the same usage level of CPUs. So if you are planning to use, and if you are using your cloud cores, please just remember these numbers in your design. Now that's an example that I'm telling truth. So these are 5 routers running over 1,000 subscribers each, and there is a 172 router which runs the BGP connection and aggregates all the traffic from all these other machines. And simple queue with parent. So this is something what MikroTik says that is the fastest way. We also work with that, but unfortunately I do not have real big deployments with thousands of customers on one router and with the high speeds. So I cannot say if it's really performing better or worse. But MikroTik says that yes. So it says like 9 times faster comparing to simple queue. What is the difference? The difference is that I take the simple queue and I attach it to some parent. So I have a parent, and on the parents, I will create simple queues. Less steps needed for processing. I can build some kind of contention aggregation scenarios on it, manage it through API, but Radius also supports setting the profile. It's a new update which was launched, I think, a few months ago. They added the option that in your Radius reply, you can also specify the profile to which you match the customer, the PPPoE profile. Contention per plan, this is something what we will show in that example, is that when we have this simple queue with the parent, we can provide aggregation. So for example, I sell 10 megabit per second, and then I will just say, okay, 10 megabit per second, I will share between 5 customers, so with contention 1 to 5. And the only one limitation on that configuration is 128, I think, IPs can be used under one parent. That's what we found. If you configure it through Winbox, it will be much less. It will be like 60 probably. If you push it through command line or through API, then it stops accepting your commands on around 128 IPs under one parent. And of course, as contention per plan, you can do the contention per router or per sector. So you say, I have a router, my access point with 20 meg connection wireless. So if my customer will start to download over this limit, my link that connects this access point will start to work not that good. So, and for this case, we can set up on access point, for example, we can set up that contention parent and say this is the 20 meg that is allowed to use on this access point in total, and all customers will share these 20 megs. It doesn't matter if one has 1 meg, second has 10 megs. Still, they will have a main limit, which will be 20 megs. That is limit for that router. Okay, showtime. Quickly, let's check this type of configuration. Okay, so that's my Winbox. And again, instead of deleting it, I'll just change it to simple queue. And I think that simple queues are already there. Just let me save, update it. And here on the queues, on the simple queues will appear, the simple queue configuration is very simple. So it's really, that's why it's called this way. On the target, we define the IP address of our customer, and then we define the max limit and limit at and the burst settings. And as I'm saying, when I use Radius, so it sets it up immediately dynamically, this simple queue. Okay, here it starts to push the simple queues. Each single line is one customer. So I don't need any mangles anymore. I don't need PCQ address list, nothing like that. So I just simply add IP address of my client, or it can be also the range that is routed to this customer, or it can be multiple IPs for the client. And then I define the speed. Here's, for example, download is for 5 meg and upload is for 1 meg. And that's all. And what I said that important here is to check what is your queue type. So the queue type here, we create own queue type, ECQ, but if you have it default small, then you can have issues with the high speeds. Because so instead of 20 megs, as I shown an example, it will provide only 15 megs. And you see there is no other things involved, so there I can still have this type for quality of service. I can disable it, and the queue types defaults. So what is the difference between the simple queue and the simple queue with parents? The difference is that when I open here the simple queue, so it updated all my configuration, I hope that you cached it, so it's coded. So this is the, look, tariff main is the speed of 2 megs that all customers under it will share. So 1 to 5 contention is this scenario. So if all customers will start to download immediately, they will share this speed. What is important to have is that all customers, you see this is incorrect configuration, for example, here. And incorrect is limit adds of all these lines will give me more than my maximum limit of the parent. So that I shown you exactly this mistake that will lead to misconfiguration and behavior or unpredictable behavior, let's say, of the shaping. You must define that your limit add of each single client under the parent. So if you count them all and you will get the sum, it should be less than the main speed of the whole parent. So this again is the contention scenario when we have 5 megs. 5 megs, 5 customers under it. Each single customer has limit add on 1 meg, and if we count it, it's 5 meg. So it's a maximum speed of the whole parent. This is fine. Please here be aware of one thing. When you create parents, you must always set up to the parent all IPs of the customers that are under it. So if you not set it up, it will not work. And that will bring you that limitation that if you will do it like 129 or 150 customers under one parent, that will not allow you to do that. And you can set up these queues also with radius, with new update. I think it was not possible in the past. Now it's possible. You can, when radius will set up the speed limitation for a customer, you can define the profile that it should use. And under profile settings, on the PPP, as you know, there is a radius tree profile for this example. There is an option to set up parent queue. So it means that if queue is created dynamically, we can put it under selected parent. And according to MikroTik, it will lead to better performance. So please try this and share your experience, share your results. And one thing about the quality of service and router OS. So all guys, you look like this one, so overloaded with technical information. Please smile a bit. Let's move to quality of service. Where to set up quality of service? On central NAS, on access point, or on CPE? When we define it on central NAS, the problem is that quality of service, it works only when the maximum limit of your parent is reached. So imagine the situation that you have a main router with 500 megs on it, and now, but it's on a gigabit port. And now to provide QoS on that router, you have to set up the main parent for that router, and you will limit your speed to 500 megs, for example. But what if your customers will get more than 500 megs? You will, by queue, you will limit them. So that's why personally I do not like this type of applying the quality of service on the central routers, Better is to do it on access point, or we, for example, we do it mainly on CPE devices. When we really need to define the quality of service, there's a customer which is company and they have a voice and they need this kind of setup, so we define it on CPE. And where to set up the user shaping, I recommend, and I think it's industry standard, that you use automatic and central approach. Use PVPoE servers, IPoE, DHCP default gateways, or it can be also done on access point. Personally, I do not set up the queues on access points because all my access points we run on the bridge mode, and then it goes to the provider edge of the MPLS network. So that's to improve the performance of the router itself. That's all. Finally, and thank you for your time. MikroTik, thank you for RouterOS. Valens, Riadi, thank you for a few slides that I took from your other presentation. And Andres Ruiz is my good friend. He shared with me the quality of service configs from his real network. And thank you, Groot, for pictures. That's my contact. If you have any questions, just send me to alexplinks.com, the website, and this is the GitHub, so the presentation will be available. You can download all the scripts that I use, all the examples, configuration, you can download it from there. I will maybe update all there. There are just few now. And so the Facebook and Twitter of my company is the ISP framework. So if you have any questions about that, there is one. Can we give a microphone? I don't know if, Normis, do we have a microphone? Okay, guys, maybe if you have questions, I will be there on the stand. Just visit me and ask me about that. Okay? That's all. Thank you.